In this video, we're going to talk about multiplicity. And multiplicity is the number of times a factor occurs when a polynomial has been factored. So to find the multiplicity, you do have to factor it or be given it in factored form. And so once you find its factored form, if it has an even multiplicity at that factored number, at that solution, then at that place, the graph is going to touch the x-axis right there. So for example, if you're given like this is like a parabola, okay, it's not going to go through that x-axis. It's going to come over, it's going to touch it at that solution, and then it's going to bounce back. And it can happen when it's on top. So it'll go from, top, touch that axis and go back up, or it could even be down here where it's coming up. It's going to touch that x-axis and then come back down. Okay, so that's what I mean by touch. And then if it has an odd multiplicity, then it's actually going to cross through. So it's not going to touch it and bounce back up. It's going to go through and then it's going to turn around somewhere. It can come back through and then it'll come up somewhere and turn around and come back through. So crosses, goes through the x-axis, and touches, it's going to touch it and then bounce back in that same direction. So find the zeros and state the multiplicity. Okay, so I'm going to make a little chart. Okay, so right here at x minus 3, what is my 0 there? So this is already factored for us. Once it's in factored form, we would do x minus 3 equals 0. We would add that 3 over to both sides, and then we would find out that x equals a positive 3. So my 0 is at 3. So then what is its multiplicity? Well, I have an x minus 3, an x minus 3, and an x minus 3. How many times is that occurring at a 0 of 3? 3 times. So my multiplicity is 3, which is odd. And so that means that at 3, that graph is going to cross through at 3. And then we have x plus 2 equals 0. So if you do x plus 2 equals 0, you're going to subtract that over. So we'd get a 0 at negative 2. And what is its multiplicity? Well, that's the only one that we get. So its multiplicity is 1, which means at that 0, it's also going to cross through. Okay, so just to kind of give you a better understanding of what it is that we're finding. Okay, we have a 0 at 3. We have a 0 at negative 2. And I don't really know my end behavior yet. Okay. But what we're saying is that it's going to come down here, or it could go up and go through, but it's going to cross through because my multiplicity is odd at my 0 of negative 2. It's going to cross through here. I don't know what's going to happen up here. It could squiggle. It could do whatever. Might do something like this, but I know it's going to come back through and it's going to cross at these 2 zeros. Okay, is what we're finding. Okay, similarly here. This one was all spread out. This one, they've kind of chunked them up for us. So if I do my same chart, okay, -5 is just a constant, so I'm not worried about that, but we've got x plus 1 to the 4th power. So again, if you set this equal to 0, x plus 4 equals 0, you're going to subtract that 1 over, and we get a 0 at -1. Its multiplicity is the amount of times that it's occurring, which is at 4. So I have a multiplicity of 4. So what that means is at -1, this graph right here is actually just going to touch, and it's going to bounce back either up or down. Okay, we have another one right here at x minus 2. So if I set x minus 2 equal to 0, we would add that 2 over. We'd get a 0 at 2. And then its multiplicity is the number of times you have that factor. In this case, it's 3. So here, it's actually going to cross through at 2. Now, don't forget this other x here. If you just have x equals 0, we have 5 x's. So we have a 0 at 0, and its multiplicity is still that exponent. It's 5, which means it's also going to cross through right there at 0. Okay, so again, if I'm showing this, okay, we have a 0 at -1. We have a 0 at 0 and at 2. Okay, so at -1, it's just going to touch. So if it starts down here again, it's going to come over here, it's going to hit that -1, and it's going to bounce back down. Because I found that my multiplicity is even, which means it just touches. But then here at 0, it's actually going to cross through. And then at 2, it's also going to cross through. And again, I have no idea what's happening between these zeros. So this could have squiggled down here. This one can do all kinds of squiggling up here. Okay, I'm not sure what's happening between these zeros, but I know at -1, it's going to come over here. It's going to touch it and bounce back. And again, I don't know really where it's starting. We don't know in behavior yet. Okay, but it's going to touch, it's going to bounce back, but then it's going to cross through at 0, and it's going to cross through at 2. On here, we're kind of doing this portion backwards. Now we're going to be given this information and have to write some kind of polynomial function. So form a polynomial whose zeros and degree are given. So I have a 0 at -1. So that means I have we've got x plus 1, right? If you set x plus 1 equal to 0, you subtract that 1. So these are always going to be kind of opposite, right? We had a 0 at 3, but this was x minus 3. We had a 0 at -2, but it was x plus 2. And it tells me my multiplicity is 2, so I know that that is squared. And then we have a 0 at 3, so that means we have x minus 3, and its multiplicity is 1. So you can put to the first, but it's not really necessary. And then we need to make sure that we have a degree of 3, and we do. You've got 2 x's here plus 1 x here, so that is a degree of 3. Okay, we have zeros at -3 with a multiplicity of 4, and a 0 at 5 with a multiplicity of 2. We should have a degree of 6. So if I have a 0 at -3, that means that this is x plus 3. Its multiplicity is 4, so this is to the 4th power. We have a 0 at 5, which means this is x minus 5. And it has a multiplicity of 2, which means that this is squared. And we need a degree of 6, and that's what we have because I have 4 x's here, 2 x's here, so I have 6 x's total. Okay, so now we're going to basically do this again, but based off of its graph. So use the graph to solve f of x equals 0. So you're solving, right? That's another way to say when y equals 0. And when this y equals 0, here are your x's. That's what your x-intercepts are. So let's find the factorization of f of x and use the smallest degree possible. So if I'm using the smallest degree possible, that means for odd, we will use 1. And for even, we will use 2. So here, my zeros are -1, 1, and 2. We got -1, 1, and 2. So when I factor this, this is this -1 becomes x plus 1. This +1 is x minus 1. And this 2 is x minus 2. So now I just have to figure out, is it odd or is it even? Well, right here, because at -1, it is crossing through that point, that makes this one here odd. And so I'm going to leave this to the first power. And I don't need that 1, but I'm going to put that there just so we can see what we have. Okay, right here at 1, this is not crossing through, it is touching, right? It's hitting that 1 and it's bouncing. So this one here is even. So that means I need this one here to be squared. And then lastly at 2, it is crossing through. If it crosses through, that means it's odd. And so I'm going to leave that to the first power. And so that's my final answer there. It wants you to use the smallest degree possible because I don't really know what this is. This could be cubed. This could be to the 5th. This could be to the 7th. It could keep going forever. And so we're just going to label it with the smallest degree possible, which is going to be 1 in this one. And same thing with your evens, right? This could be squared. This could be to the 4th. This could be to the 6th. I don't really know. And so it's going to want just 1s and 2s here. Just because we don't know just by looking at this. Okay, now this one is similar because it's got the same zeros here. We've got x equals -1, 1, and 2. It's crossing here. So that one is odd. What is this one? I hope you said odd because it's crossing through. And what's this one? It is odd again because again, it is crossing through. So our answers are almost the same. You've got x plus 1 here. Because it's odd, it's to the first, and I'm not going to do it this time. For this one, you've got x minus 1. Again, it's odd, so it's to the first, but I'm not going to put that. And then for 2, you've got x minus 2, and it's odd, so that's to the first, but I'm going to leave it just like that is.